Alright, so here we're going to be talking about GCF and factor by grouping. So finding the GCF, which is the greatest common factor of a list. The first thing we're going to do is we're going to find the GCF of the numbers, the GCF of each variable, and then we're going to go ahead and multiply those together. So let's go ahead and start off with the first example, finding the GCF of these three terms here. So we're going to go ahead and list the numbers. So this is very similar to the GCF, but it's a little bit different. What you want to do is do the prime factorization of each one of those. So that means just list them in multiplication with just primes. So this one would be 2 times 2 times 5, that gives you 20. And then 2 times 5 gives you 10, and 7 times 5. And then you want to circle everything that they have in common. So they all have a 5 in common, and that's about it. So that would be your greatest common factor. Then we're going to move on to the variables. So the first one here is x to the third y. So we're going to go ahead and write this out as 3 x's and 1 y. And then you have x squared and y squared. So we're going to write it out as 2 x's, and then the y, we're just going to write it over here. And lastly, we just have an x to the third. So 3 x's. So we'll circle what they have in common. So they have this x in common, and they have another x in common. And that would be our greatest common factor for the variables. So that would be x squared. And so the greatest common factor would be 5x squared. And that's it. Okay, then now what we're going to do is we're going to factor out the GCF. So we're going to do this without doing as much work as we did over there. We're going to try to do a lot of it in our head. So the other way I like to think of the GCF is what you could divide into both of these. So let's think about the numbers here. What can I divide 8 and 4 by? I could divide 2 and 4, but you always want to choose the highest. So I'm going to factor out the 4. Okay, then you got to think about the variables. Well, I could divide this first term, x squared, by x squared, but I can't divide any variables by that one evenly. So you can't divide any variables. So now we're going to go ahead and just factor out the 4. All right, so if you factor out a 4 from 8, you're left with 2, and then you're left with the x squared. And if you factor out the 4 from the 4, you're left with a 1. You want to think about that as division. 4 divided by 4 is 1. Okay, so you still need to put that 1 there. Okay, next, let's think about the 5y squared and negative 2z to the 4th. So the 2 and the 5, I can't divide anything into them evenly, so you're done there with the numbers. And then the y, I can't, there's a y here, but there's not a y there. And then there's a z here, but there's not a z over here. So you can't divide anything out of this. So that would just be your answer. All right, so next we have 6x squared minus 3x to the third plus 12x to the fourth. So let's think about the numbers first again. So 6, 3, and 12. I could divide a 3 by all those, and there's no other higher number that I could divide all 3 of them. So 3 is the highest number that could be divided evenly into all of them. And then when you think about the variables, you have x squared, x to the third, and x to the fourth. So you could divide all of those by x squared evenly and no other higher variable. Now let's say you're a little confused. You could still do the thing that we did at the very beginning. The first one is x squared. the next one is x to the third, and then the last one is x to the fourth, so they have a total of 2 x's in common, so it would be x times x, which is x squared. Alright, and then let's finish this up. So again, this is like division. So 6 divided by 3, that leaves you a 2. And then you took out all those x's, so you're just left with the 2. Negative 3 divided by 3 is negative 1. And then if you take out 2 x's from here, you're left with just 1x. 12 divided by 3 is 4. And if you take 2 x's from here, you're left with 2. So x squared. And so this would be your factored form. All right, and the next one we have factor 17x to the third y squared minus 34x to the fourth y squared. And so we're going to think of the numbers 17 and 34. Now, maybe 34 is a multiple of 17, so let's go ahead and do 17 times 2. And I get 34, so I could take out a 17. And then let's think about the variables. So let's actually write it out like we did before. So this is an x to the third y squared, so 3 x's and 2 y's, and then 4 x's and 2 y's. Okay, so now we could go ahead and circle what we have in common. We have 1, 2, 3 x's in common and 2 y's in common. So we're going to go ahead and write that out as x, x, x times y. So that gives you x to the third y squared. This is what you're going to factor out. Okay, so for the first term, I'm taking out 17x third y squared, so you're just left with the 1 there. And then 34 divided by 17, that's 2. And if you take out of the x to the fourth, if you take out 3 x's, you're left with 1. And then you're going to take out both of those y's. So this would be your answer. All right, next one. We're going to factor out 2x minus 5 plus 3a x minus 5. Now this one, you want to kind of look at the format. And if you noticed, if you noticed, they both have an x minus 5 and an x minus 5. So we're going to go ahead and factor out that x minus 5. So if we factor out the x minus 5, what we have left here is a 2, and what we have left here is a 3a. So 2 plus 3a. And that would be our factored form. So this is what we call factoring. All right. And the last thing we're going to go over is factor by grouping. So sometimes it is possible to factor a polynomial by grouping a terms of polynomials and looking for the greatest common or the common factor in each group. So let's go ahead and start off with this first one. Factor xy minus 6x plus 2y minus 12. So I'm going to go ahead and zoom in just to give me more space. All right, and what I like to do is I like to group these two things together and then these two things together. So I like to put a line underneath, and we're going to basically go back to what we were doing before. What do these first two, x and y, have in common? So the number-wise, they don't have any numbers in common. And then what about the variables? I could factor out an x, right? So that's going to give me If I factor out an x out of this, you're just left with y. And if you factor out an x out of this, you're just left with -6. All right, so then the next one, you have 2 and 12. So the highest thing I could divide both of those is a 2, so that's going to be +2. And then I can't divide a variable because they both don't have y's. So 2 divided by 2 is 1, and -12 divided by 2 is -6. Now, if you did this part correctly, you should see that you should have the same thing in the parentheses. And that's what we're going to factor out. So we're going to go ahead and factor that out. Whatever you factor out, remember we always write that in the front. And so what we're left with is x and 2. So x plus 2. Now if we wanted to, that changed. If we wanted to, we could use the box method to check our answer here. So let's go ahead and do that quickly. You should get the original if you check your answer. So this would be xy, 6x, 2y, minus 12, xy minus 6x plus 2y minus 12. Yep, that's the original, so I did it right. All right, let's go ahead and work on this last one. So we have to group the first two things together and the last two things together. Okay, so x to the third and 5x squared, they don't have anything in common, but I could take out an x squared. That's the lowest variable, so that would be x plus 5. And then I could take out from 3x and 15, I could take out a 3. Okay, now they have that parentheses, right? That's the same. So you're going to go ahead and factor that out. So we're going to write that in the front. And then what's left over, we're going to write it in parentheses. And that would be our answer.